Hi, in this video we are going to have 6 projects using this ESP32-S3 with this LED matrix. We're going to have a basic dot that moves on the screen. Then we will have a text scrolling project to send text from your mobile phone and instantly display it. Then we will have a dot tilt where you tilt the device and the dot moves. The next project is an arrow up. No matter which way you turn it, the arrow is always up. The sixth project is a symbol or target game where when you tilt the module, the dot hits the circle and the color changes. Let's get started with this. Now, to understand the module, first we should know that this is ESP32-S3 chip. And the connectivity and programming will happen via this USB. On this side we have a 8x8, which are 64 RGB LED, RGB red, green, blue, so you can set any color you want. On this side we have a 8x8, which are 64 RGB LED, RGB red, green, blue, so you can set any color you want. And the pins are all available, so you can solder and do like regular Arduino or ESP32 to connect and control your devices. But we have also the screen. On top of all of this, we have this accelerometer, MQI8568 accelerometer, so we can detect acceleration, movement, and orientation of this device. Have a reset. When you press this, the program will restart, and this is for booting and programming for firmware. To use this with your Arduino IDE, we need to install the board for the ESP32, we need to install the library for the RGB LED, and we need to install the library for this motion 6 sensor chip. You see here it has been labeled at X, Y, and Z. So in terms of direction, this is Y, this is X, and up is the Z direction. So this is the first project. We need to install a new pixel from Adafruit. The first step, install ESP32 boards. Click on this icon, type here ESP32, and you will see ESP32, that's for Arduino. And you will see Arduino ESP32 boards, and then you will see ESP32 by Espressif system. You will see this install button here. Click. This is the latest version. Click and install. Wait for this installation to complete. Now, to install this library, we need to install new matrix library that will install everything for you. Click on library, just type here NEO matrix new matrix, and you see here new matrix. Click install. You will see this, that it will install BIOS IO, GFX, and new pixel all together. So install all. Installation is successful. After that, we need to install this accelerometer MQI8658 by Lav Gahali. So I'm double clicking and selecting it. Press Ctrl C, copy this, go to library, and then type it. You see here it says by Lava Gahali installed. So you will see this install button here. Click and install. All the library and software that you needed for this purpose will be installed. Now, to make sure that the libraries are installed, click on File, go to Examples, and scroll down until you see add a fruit new pixel. Once you see it, this is done. And then we can do also the MQ library, MQI. And here you will see MQI with 3 samples. So this is now ready. Now let's run this project. This is just moving a dot. I just changed the value so it goes left and right or whatever. This is very simple. This is the main code. If you go on File, Examples, scroll down to New Pixel and Simple. And here on this code, you must change on this code and all other codes that you see, you must change this to 14. Because on this module, this RGB LEDs are connected to pin 14 of the ESP32 here. This 16 is referring to 16 LEDs. We will change it to 64. Because here we have 8 times 8, 64 RGB LEDs. The value that I've set here is 50, so it goes very fast. The larger the number, the longer the delay. So this is the wait time or the delay. Once you're done, just click here to upload it. After that, we have to select our board. Click on, you can click here and go, but let's go also from Tool, Boards, this option, come here. You will see Arduino AVR and ESP32. From this, scroll up and down until you see ESP32-S3 dev module. So this is very important. It will not work with anything else. Once that is done, you need to select the port. Click on Tool, and you see here COM. When you connect your ESP32, you should see a COM port here. So if I disconnect it, this is now has no port. Or if I go on Tools, you see the port is great. But if I connect it again, and then click on Tools, Port, it shows. And also it shows it here. Here it says GRB. So this should be RG. R and G. If we set this R and G, then upload the code. Now this is R and this is G. So we should see this turning green. Wait for the code to upload. So now we got the correct color. The first element can go from 0 to 255. So this is red and this is green. The green is now not with a full intensity. This is just weak. You can go even 255 to make it much bright. But if you want red, just go here. Any value of brightness from 0 to 255, that is red. And this is blue. If you combine the color, you will get different colors. So with combination of these three, any color that you want, you can make your own color. Now this is blue. If you want to be able to change different color and understand the color, just go on Bing or Google, just type color picker, and you will see the color. The color is displayed in here. These are the values. For example, if you want to have this color, move this slider and move it from here with the different color that you want. For example, yellow. If I bring this to the right, for the yellow, we need to have this value, or we need to have 255, and 0 is pure yellow. Let's do it. 255, and 0. Upload it. You see now the color is changed to yellow. This is a project 2 where we have a text scroll. "14" is the pen that is used by the board. 8 by 8 is the length of our text. Two things to remember: this is GRB, the proper match is RGB, and we will see later on this one. The text that you want to display is this one. For example, right now it's Robojax. This is the brightness and the scroll delay, how fast or slow it scrolls. The rest has no setting or anything. So I've written Robojax. If you want to change the color, just scroll down below this here, because the red is now to set the color, come down here. Now I set the color to be red, so 255, that means the maximum redness. And if you want to set green, between 0 to 255, the same way blue. And now the color has changed to red. And this is our third project, HTTP text, where we can send the text from our mobile phone. The setup that you have is, this is a SSID for your Wi-Fi and for the password. This will connect to your router. If your router is not available, it can work as an access point, so you can connect your phone or computer to this module that acts as an access point or a Wi-Fi router, so you can get connected. Pin 14, and then these are the length and the brightness of the text. So the color, the text that initially is in here, then the rest we can set it from the program. Once you upload the code, just click here again and it will print. So it has been connected to this Wi-Fi, and this is the address. Open the new tab, Control V, paste it, and go. Here is the screen. As you can see, this is the text. Now we can select different color and then apply. The color changes automatically, generated by the module. So this is producing this screen with all the text. It's coming from this, so this is acting as a server. Now the color is white, the text is hello. Let's change the color. Let's say set it to red. Okay, and then apply. As soon as I click, the color changed. Let's change the text to Robojax. Apply. It changed to Robojax. And if I want to change it to something like this type, green. Now here we can slow it down or speed it up. Apply. Now this is too slow. Hello? If you want to speed it up, too fast. So somewhere in here perhaps is the right speed. These are the 4 keys that you can change the scroll. Right now it's scrolling to the left. Let's go up. So now it's going up, down, it goes down. Right was not useful, but still I implemented it. So that's it. So it works perfectly. Okay, now I opened my browser and I've entered the same IP address 192.168.1.16. So right now it says Robojax and green. Let's change it to red. Set and then apply. It changed. Change the scroll going that way. Top, bottom, or let's go for this kind of blue. That's much better. As I'm preparing for the next video, please thumb up the video, and if you haven't subscribed to my channel, please do so now. This is now the tilt project, where we will detect the tilting of the device. Everything is the same. You just set the pin 14 and then 8x8 is the matrix, and then these two are GRB. Make sure to change it to RGB. So B is staying the same, just R and G has been replaced, and this portion is progressive. The rest we don't have any settings. Oh, here you can set the color for the dot. These 3 are for red, green, blue. So dot red, green, blue, which means now right now it's green 100, which means light green. Let's upload the code. Once the code is uploaded, we will see a dot here that is determined by the this accelerometer. So it will determine if the board is tilted or flat or not. Then the dot should move accordingly. Okay, so right now this is the color, the light green. Depends on the position of the board. Let me tilt it up like that. As I tilt it up, it knows that it has been tilted, so it goes up like that. If I tilt it this way, this side is up, and if I go to the left or right, you see we can change the direction whichever way we want. So we were able to detect the position or the flatness of the board with the motion sensor. This is the code for Arrow app. We detect the position of the board using this motion sensor or accelerometer, and we set the same pin. 8x8 is for the matrix, and the color dot for the dot is set here. Upload the code. After that, now when the code is uploaded, this is our dot, and right now we are flat. If I lift this up, you will see that it shows arrow pointing up. So it's telling us this side is up. Now if I point this up, it goes this way. If I point this like that, so this side is up. The arrow points always up, no matter what. I'm holding it like that, so that's up. Or if I hold it like this, that's up. Very cool. For this demonstration, without wiring, I've attached this buzzer. The positive is connected to pin 6, and the ground is connected to the pin ground here. Now, this is our code. Now the project is running. The dot is in here. So we are holding it. Every time the dot touches the circle, it changes the color and also it buzzes. Because the color is random, sometimes it might happen that we get the same color. You see? Now, blue, red,